Well, you probably hear in the background some thunder and lightning and some rain, and that's just the nature of mathematics. Is when we start talking math, it really becomes violent and rain comes about. So we're going to continue with now lesson 2-8, which is about the reciprocal of a real number. Remember that your real numbers are like your integers, your fractions, your decimals. That includes all the real numbers that we work with. Our objective is the student will be able to simplify expressions involving reciprocals. So our goal is to simplify those expressions, to find their value. And we're going to be using reciprocals to do it. So it's a distinct case of simplifying expression. The property that we're looking at is the property of reciprocals. And this is saying that for every real number, A, which could be any real number, there is a unique real number 1 over A, such that A times 1 over A equals 1. And if we use the commutative property, it would be 1 over A times A is also equal to 1. An example would be if we had the number 5, the reciprocal of 5 would be 1 over 5, and we would note that their product, 5 times 1 over 5, 5's cancel out, and that would just become 1. So reciprocals have that property that when they're multiplied together, the result is going to be 1. Now there are exceptions. Okay, there are exceptions to this. And matter of fact, when we look at some of the problems, you'll see some of the exceptions. Let me just, in your textbook, you'll note on page 79, they list 6 examples, and they're like different cases. The first one is the 5 and the 1 over 5 for properties, you might say, like of a whole number or an integer. Then the example 2 they have there is a fraction, 4/5. The reciprocal of 4/5 is 5 over 4. Then they throw in a decimal. And it's not something you normally think of, but the reciprocal of minus 1 and 25/100 is minus 8/10. So when you multiply 1 and 25/100 times 8/10, the result's going to be 1. I don't normally think in terms of decimals. I usually think in terms of fractions. But it is a true statement. It follows the property. When we come to 1, the reciprocal of 1 is 1, so it's its own reciprocal. Likewise, for minus 1, it's its own reciprocal. And then we have the last one, it has 0, has no reciprocal, because 0 times any number is going to be 0 and never could turn out to be 1. So that's the general setup in terms of the objective is to simplify expressions using reciprocals. And then the property of reciprocals we're looking at is a number times its reciprocal is 1. So that's what we'll be aiming towards. So now let's look at some problems from your book. And they're on page 80 and 81. Or I put some over here where we're finding reciprocals. I just added them in so I could get some different cases, different ways of looking at it. So first of all, the reciprocal of 7 is going to be, 1 over 7. Now when we come to the reciprocal of a negative number, it's still going to be a negative number, except it's going to be 1 over that negative number. Now you could write this in one of 3 ways. 1 over a minus 2, that's the same as minus 1 over 2, which would also be the same as minus 1 over 2. So that reciprocal could be written in 3 different ways, and they're all equivalent. When we come to a fraction, it's just flip it. Just change it there. So this would become 4/3. Right? So the reciprocal of 3/4 is 4/3. I put in a mixed number down here so that you can think in terms of how you could work that mixed number, first of all, into an improper fraction, which would be 3 times 1 is 3 plus 2 is 5. So that would be 5/3 would be the improper fraction. And now it falls back to this case here, where the reciprocal of 5/3 is going to be 3/5. So that's some general cases that we would see in terms of finding reciprocals. Now let's apply it to some expressions to simplify the expressions for us. When we look at 1/5 of a -20, what we're going to do here is keep our 1/5, but now take the -20 so that we get the factors of it, and one of those factors is going to be 5. So this becomes 5 times a -4. That will give us the -20. Now we can see here 1/5 times 5, a number times its reciprocal is 1. So that's going to come out to be 1 times a -4, which is a -4. So it's a simple way of working your expressions by finding reciprocals within the products. Now the next one here is your number 5 in your text, and it has 96 times -1/8 times -1/12. And being a textbook question, it almost says it probably 8 times 12 is going to be 96, and it is true. So what we can do then is take our 96 and have then products 8 times 12 times a -1/8 times a -1/12. Now by commutative property, we can have, that'd be commutative property, all right, be 8 times a -1/8 times 12 times a -1/12. And we can see we have 8 and its product, but we also have that negative sign here. So we're going to be retaining the negative, but then we have 8 times a -1/8 is going to be a 1, that'd be a -1 times, we're going to retain the negative sign, 12 times its reciprocal, 1/12, is going to be 1. And now we end up with a -1 times a -1, which would be a +1. In this case here, they introduce some of the variables, but we're still doing the same process here. If you'll note, we have 15 times n times 1/5. We can break our 15 out into 3 times 5, and by the commutative property, bring that 1/5 over here next to the 5, and then retain our m and n. So now this becomes simplified. 5 times its reciprocal is 1, and this would therefore come out to be 3 times 1, which is 3mn. The last one I put in here just so that you can see about that, the denominator, we can't let the denominator be 0 because then it becomes undefined. And so in the problems it will say where t is not equal to 0. So we're actually looking at the reciprocal of a variable, t and 1/t. So this then we can put together as 7 times t times 1/t. The number t times its reciprocal, 1/t is 1. Therefore this becomes 7 times 1, or 7. So what we were looking at in this lesson is taking reciprocals of a number and making use of those reciprocals to simplify each expression.